Hello, everybody, and thank you for joining us today for our webinar from the INSITE programme, which for the last 10 years has been looking at some of the fundamental science questions needed to understand the influence and value of structures in our marine environment. My name is Dickon Howell, and I'm the programme director for INSITE, and I'm just going to introduce the webinars today. One moment. Before we go into the presentation today, I just want to make a point about the use of science in decision-making. Those in government who are making decisions are invariably dealing with multiple and competing interests, and their decisions need to be made in a transparent, accountable and proportionate way. Science plays a critical role in informing decision-making and enabling action, particularly in identifying alternatives and clarifying the costs and benefits of particular courses of action so that policymakers can choose between them. What we've been doing in the INSITE programme over the last few months, and will continue to do over the next 12 months, is to work closely with policymakers to identify where the INSITE science of the last decade can support their work. INSITE's coming to the end of its second phase. Many of you will be familiar with the programme, but it's worth saying that when INSITE was set up, it was the first real joint industry partnership of its kind in UK marine research. And its aim has always been to provide stakeholders with the independent scientific evidence to better understand the influence of man-made structures on the ecosystem of the North Sea. I'm not going to go through this slide in detail, but I just wanted to show you the breadth of work being undertaken in the science programme of INSITE. We're looking at topics as broad-ranging as foraging by marine predators, testing the limits of the UK autonomous fleet, understanding fish aggregation and blue carbon benefits, and developing AI to speed up the understanding of biodiversity on marine structures. The webinar today is going to feature marine biodiversity insights from projects led by three of INSITE's principal investigators. First to talk will be Professor Joanne Porter from Heriot-Watt, then Dr. Tom Welding from SAMS, and then Dr. Paul Summerfield from Plymouth Marine Laboratory. Following on from our scientific insights, we'll have Victoria Metheringham, who's not a doctor, who she reminded me this morning from DEFRA, to provide us with some marine policy related insights for consideration alongside the marine biodiversity findings. And we're really lucky to have Victoria with us here today. And finally, I'll host a short Q&A session towards the end of the webinar, in which there'll be opportunity to ask our speakers any questions you have about the talks today. All attendees are going to be muted throughout the webinar, but you can ask questions or comment as we go along via the Q&A tab in the Zoom tab at the bottom of your screens. It'd be great if you can upvote any questions you like using the thumbs up icons to highlight the interest in that question, and then we can take that question at the end and make sure that we are asking the one that is the most popular. And one final note before we hear from our first speaker is that in addition to this webinar being recorded, we've also got a live illustration that's going to be carried out alongside all the talks and the Q&A session. You'll be able to see that live in one of the speaker boxes during the Q&A session, and we'll give you glimpses as we can as we go along, but it will mainly be at the end, and the final images are going to be made available via the website. This is something new that we're trialing today for the first time, and if it works well, we're hoping it will become a central part of our webinars as we go forward. So without further ado, we hope you enjoy the webinar. I'm going to pop up between speakers just to do the handover and introduce our speakers. But first up is going to be Joe Porter from Heriot-Watt. So Joe, I'm going to stop sharing my screen, and if you could share yours, that would be great.
Thank you, Dickon.
Perfect. Great.
Hi, everybody. Thank you for inviting me to take part in this webinar today, a subject of biodiversity, which I think is very dear to a lot of us in the room. And I'm going to just start off by saying that I'm the leader for the Chase Sands project. And you can see from the first slide here, there's a very large number of colleagues participating in this work, and it's also quite cross-disciplinary. The main aim of our project is to enhance our understanding of the connectivity of the hard substrate epifauna across the artificial substrate ecosystem of the North Sea. And I think you can see here what we're talking about. It's the kind of things that are growing on structures. And you can see from the map below that there's rather a lot of those structures out there. So it's quite a complex ecosystem. And just to give a bit more context, our particular project relates to challenge 1 of the INSITE programme, which is understanding the role of these man-made structures as an interconnected hard substrate network. So one of the first things we did in our programme was to undertake a literature review. We wanted to understand which of the key species that we could use in the study to understand the connectivity. And here you can see we've just got a table highlighting some of the shortlisted candidate species that we'll probably be focusing on as we get deeper into the work that we're doing. And as part of this process, we had to undertake an overview of the constraints on why some species would be more useful to use for the questions that we want to answer. So some of the constraints are to do with how much of the tissue that we can get for part of our work. We also were interested in distribution vectors, and this relates to non-native species. And we're also interested in things that are not genetically too complicated. For example, if we get into cryptogenetics, that can make the analysis quite a lot more complex to perform. So just to reiterate, these are the main species that we've got shortlisted as part of our programme of the field research. Now, we've also looking at this in 2 different ways. We're looking at physical settlement onto structures that we put out, but we're also looking at modelling work and looking at connectivity analysis using particle tracking processes. And this is to do with larval dispersal. So we've selected out from some of those species, those that have traits which are particularly important for the hard substrate analysis. And this is the work coming out from the National Oceanography Centre, led by Michaela de Dominicis and her RA Ben Barton. And they've been releasing particles in specific areas in the northern part of the North Sea, and then following where those particles end up. And what you can see in the diagrams here is the particles being released and then moving over time and stretching out and moving across the North Sea. And this is using models from the Scottish shelf model that have been adapted for this process. And this helps us to understand how particular types of biodiversity to different types of species are connected. And it's helped us to design also where we wanted to put out our panels to observe the recruitment and settlement of species in the North Sea. So you can see here, with help from Aquaterra, we've been looking at a site selection process for offshore deployment. And we've settled on some sites here associated with wind farms, some sites across the central area, and then some sites much further out with close association with oil and gas infrastructure. It's been quite a difficult process, the site selection, but we've joined with some very good partners now who've been extremely helpful in enabling this work to go ahead. And we've also done a pilot survey to test out our settlement panel structure to make sure that it's suitable for offshore conditions. And these have been designed, and then we've tested them out at the EMEC sites in Orkney, which is a pretty good test of infrastructure given the extreme conditions here. So you can see a few pictures here from a recent collection retrieval process that we've developed, and some of the initial hard substrate assemblages that we're observing. And so you can see there's quite a lot of biodiversity information starting to come through. And we're looking at in terms of the laboratory analysis, doing detailed analysis of what comes in on these panels, looking at different substrate types. We're looking at an image analysis process and the workflow for that. And we're trying to automate some of that where it's possible to do so. And we're also using this information to inform the choice of tissue sampling, which will then lead on in later work package to the DNA analysis for the connectivity, the genetic connectivity. So the point of today's webinar is to think a little bit and discuss a bit how our work on this biodiversity coming out from the Chase Sands programme can be useful for informing the oil and gas and the offshore wind infrastructure operation and decommissioning. And you can see in the image here some of those different types of operations that take place out in the North Sea. So let's just thinking standing back from this about the North Sea hard substrate ecosystem. We know that in times gone by, this area hosted extensive shellfish reefs, which supported fish, birds and cetaceans, and in fact right through the trophic levels. What we've got now is quite extensive sedimentary areas with numerous islands of artificial structures. And so over time, we've had a sort of removal and fragmentation of habitats, and this has resulted in biodiversity losses and biodiversity gains. But I think the question that's quite pertinent is, what could the future look like for the North Sea? What could it look like in 5 years, 10 years and beyond? We've got an opportunity to reduce the fragmentation and to promote ecological coherence across this ecosystem. And we've got an opportunity to enhance regional ecosystem services. We know that if we can enhance biodiversity, this will also help to support specific fishery types and to enhance carbon sequestration. But we've also got some challenges because we need to balance this against issues of the spread of non-native and nuisance species, which involves understanding the vectors and routes of infection and also monitoring for that and being able to come in at an early stage and pick up issues. So I think some key questions are, at what scales could and should ecosystems be restored as part of decommissioning processes? And how could that be integrated and then be embedded into the decommissioning processes and support, and enhance, add value to the transition to net zero carbon emissions? And I'm saying this because these habitats that are biodiversity rich are often the habitats that are the ones sequestering the carbon. Just to make that link very clear. So just looking in brief at the potential policy linkages, biodiversity net gain, is there a way of using some of the structures as a basis for reef restoration to enhance the biodiversity gain? And looking at the MMO strategic plan, it says that they want to have well-functioning ecosystems. Can we look at this and say what ecosystems are needed? Where are they needed? Can and should they be co-located as part of decommissioning and development of offshore wind? How long does it take for them to become established and functioning? So I'll stop there, but hopefully that gives some thoughts and considerations that we can pick up later on in the Q&A. Thank you very much for your attention, and back to you, Dickon.
Thanks, Joe. That was great. It's really interesting. I'm always massively impressed when you can get all of that research into less than 10 minutes. So yes, that's really brilliant. Thank you very much. And thank you for keeping to time. We've already had some questions coming in, but as I say, we'll keep those to the end. Next up, we've got Tom Welding from SAMS. And Tom's going to talk to us about some of the work he's been doing, combining AI with biodiversity and ecological research. So Tom, if you'd like to turn your video on and share your screen, that would be great. Right, over to you.
Thank you, Dickon, and good morning, everyone. Could you just confirm you can see that, someone?
Yes, that's all looking great. Cheers, Tom.
Okay, thanks very much. Right, so yeah, I'm Tom Welding, and I'm at SAMS, the Scottish Association for Marine Science, and I'm going to be talking about the North Sea 3D project, which is about automating the process of marine growth identification and the estimation of the biomass of that marine growth. Before I dive into the detail, I just want to introduce two of my colleagues that are working on this. John Halpin is really in charge of the image analysis and the convolutional neural nets, and Joe Marlowe does the photography and the 3D photogrammetry. And this presentation is really their work as much as anyone's. Our core objectives within North Sea 3D were firstly to identify key marine growth assemblages and develop methods for their biomass estimation, and then to train machines to identify key taxa in marine growth assemblages from the video footage, and then use and combine these outputs from objectives 1 and 2 to estimate marine growth assemblages across the entirety of the North Sea. In terms of linking this to the sort of biodiversity theme more explicitly, we're generating standard operating procedures for data gathering in terms of ROV methodology. That's remotely operated vehicles, getting the video data, and we're proving the utility of machines in identifying key members of biodiverse assemblages, and we're quantifying that biodiversity or quantifying biodiversity relevant taxa, and that would include, for example, cold water corals, which we've heard Joe mention. We're able to quantify the amount of that particular taxa, and others too. I just by way of an introduction to 3D photogrammetry and how does it work, it stitches together standard photographs that you take with your phone or a camera. It identifies common points in those images, and from that it generates effectively a dense point cloud of coordinates in the X, Y, and Z planes. So to generate a 3D model, you just take lots of images of around the feature of interest. Of course, though, the camera cannot see what it cannot see, and that in our context of biomass estimation includes the interstitial voids that the camera can't see. And so any model, any 3D model of a marine biota needs calibration when you're converting the volume to mass, which is what we're fundamentally interested in. So we've been doing this, and for some species like Desmophyllum pituusum, the cold water coral, that's relatively a relatively good and consistent relationship with the photogrammetric volume here on the x-axis versus the dry weight on the y-axis, and you can see there's a nice relationship there. For other taxa, it's more complicated, and on the right here we can see the graphs for Metridium dianthus, which is the plumose anemone, which colonizes which is a very dominant taxon on marine structures, and the dry weight relationship between the photogrammetric volume depends very much on whether the feeding tentacles are in or are retracted in blue or extended in the orange here. And to illustrate this and to illustrate a 3D model from our aquarium work, We can look at this image. Hopefully that's spinning for you. It's a model, so this is not a photograph, it's a model of Metridium dianthus, the plumose anemone. And this model is when these individuals are attracted. If you add food, they come out and get that food, and so the same individuals increase their biovolume from what's it, 800 to over 2,000. And that's an ongoing technical challenge for us in terms of interpreting our models. We can generate similar models from industry footage, so extending it from, in a sense, the ideal aquarium setting, and the results are very encouraging. This is a model, well, it's a photo of a model. It's not a photo in itself. It doesn't quite do the modeling process justice at the moment, but it is a model of cold water corals, and we've got lots of these models from North Sea structures. Cold water corals are, of course, biodiversity hotspots, and we can generate excellent models from industry ROV footage, and that will help us understand the importance of these sorts of these assemblages in hosting biodiverse assemblages. In terms of moving on to automated image analysis, then a tiny bit of background to that. Technological innovations mean that underwater imagery is increasingly cheap and easy to obtain, and the quality of the imagery is going up as well, and that's really important if you're wishing to make 3D models from it. However, underwater imagery is very time-consuming to assess, at least if you're using humans to do that, and that won't change even as the amount of data or the cost of getting the data decreases. The cost of analyzing it is only likely to increase if humans are involved. So machines or algorithms, well, we are going to need machines to help us in assessing this footage. And machines can be trained to identify features in images, and that's what we've demonstrated as part of the North Sea 3D project. So we've developed machines that are optimized for marine image analysis. So the marine images pose all sorts of additional challenges around water turbidity, for example. But we've trained machines that can identify really any element of biodiversity that can be observed by a human in underwater images. So the take-home message here is that if a human can identify it in an underwater image, then we can train a machine to do so. And we've developed combined 3D models and auto ID on diver-based footage, and this is what I'll show you to start with. We're going to look at the footage first with auto ID applied to individual frames, and this will illustrate how key taxa are identified by the machine that we've trained. So the machine is trained on North Sea footage, but is applied to a different environment. So it demonstrates that the machine generalizes very well, which is important. And we've added, though, the urchin Echinus esculentus to assist in this demonstration. What we see here is the camera view. So this is the view from a diver, as it were, swimming along a transect. And then we've got the auto ID on the right-hand side. And you can see here that the urchin here, which you can just see from the camera view, is identified here. And this image is going to jump forward as we move to other bits of it. It makes you feel a bit seasick, so apologies for that. But you can see the machine is picking up key taxa in this. So we've got the dead man's fingers here in green and Metridium dianthus related to in the middle of the quadrat there in the yellow in this example. And we can continue along the transect, picking up and identifying pixel by pixel all the taxa in which we are interested. And it picks up really quite difficult to see taxa. There's a Metridium there that you can just see, but the machine does pick it up. So that's encouraging. And we can stick these images and create a 3D photomosaic from them with the automated identification applied on top. And this is what this should show you. Hopefully you can see that. So this is the same footage as you've just seen, only it's been rendered into a 3D model, and the auto ID will be applied, generating different colors and identifying the taxa of key interest to us. And this can be applied to the 4 taxa that we've identified here and more beyond. And we can apply that technology to industry ROV footage, and this footage demonstrates how we've done that. So this is a riser from the North Sea. It's covered in marine growth, and at the top here, just coming into view, is Desmophyllum. And when we apply the machine, a trained machine over that model, we can identify in 3 dimensions each pixel associated with the taxa in which we're interested. And we can apply that finally to demonstrate again how good the machine is to another key taxon in which we're interested, which is the edible mussel, Nyctis edulis, which is a very dominant taxon on North Sea footage. This is from our own ROV footage, and it's from a local bridge support structures. And so here we have the structure. The orange is in a sense, the rusty metal on which these mussels are growing. You can't really see them as mussels by eye, but the machine can see them once it's trained appropriately, and it will color code them, hopefully a nice pink or purple color like that. And it's very good at identifying mussels and creating a auto-identified 3D model of, in this case, Nyctis. So to summarize, image analysis will inform biodiversity, health, and restoration assessments of key biotopes associated with man-made structures and beyond, actually. We can train machines to identify anything that we can see in video footage, and that will include non-native species. And image analysis of the type that I've just described will enable an assessment over relevant, i.e. large scales. And I think it will be increasingly essential as we move to more widespread adoption of autonomous data collection, for example, using autonomous underwater vehicles. And the utilization of the techniques shown here will provide essential evidence to the management of offshore commissioning and decommissioning, including this issue of environmental net gain. So that concludes my brief presentation. Thank you very much indeed.
Thank you, Tom. I always love seeing your videos, and it's great to see that intersection of technology and ecology come together. So thank you very much. Next up, we've got Paul Summerfield, who's going to talk to us both about the DREAMS project, which he's leading, but also the synthesis work, which we've been doing, which is bringing together experts across the INSITE programme and the global community. So over to you, Paul.
Coming up.
Great, I can see that fine.
Does it all look all right?
Yeah, all good.
Good. Okay. Hello, everybody. Glad you could all come, and hope you're enjoying yourselves. My name is Paul Summerfield from the Plymouth Marine Laboratory, and I'm going to talk about some thoughts about biodiversity culled from 2 rather different projects that I head up, which are collaborations with other organizations, particularly the University of Plymouth and CFAS. So just to introduce you to the 2 projects, DREAMS, which stands for Decommissioning Relative Effects of Alternative Management Scenarios, asks, what does the science tell us, and how can this be used to inform decisions about different decommissioning strategies? Going back to Dickens' opening statement from Lord May, scientists' job is to provide options and evidence. It's not to make decisions. So that's largely what DREAMS is about, providing evidence for what might happen under different situations. And it involves a lot of evidence synthesis, meta-analyses, ecosystem modeling, putting structures into ecosystem models, also some of the connectivity work, similar to what Joe was talking about earlier, and then linking through to ecosystem services, which addresses the natural capital approaches and so on that we net gain that both Tom and Joe have mentioned already. The synthesis project came about in discussions about whether scientists have a collective view on things. And it's very much about what scientists think. So it asks, is there a consensus view among scientists about what effects structures have and what to do with structures at the end of their lives? And it's a global project, involves scientists from around the world, including all the INSITE PIs. We've put them through a structured process to try and sample their brains to see what they actually think. And that approach will allow us to address questions that can't be directly addressed by doing traditional research. So that's proving quite interesting at the moment. So enough of that. What I've done is I've just pulled out some biodiversity messages from these projects, and I'll give you the messages, and then I'll give you some of the evidence behind them, if you like. So first, I want to discuss what is the evidence for effects of man-made structures on biodiversity and ecosystems. And we can say with absolute certainty that there have been many published peer-reviewed studies of the biodiversity on and around man-made structures in the sea. But we can also see that the main focus of these has been fairly limited. It's mainly been on fish and invertebrate communities close to or inhabiting the structures themselves. And these communities may be very abundant and they may be very diverse. But there are also very clear gaps in our knowledge about the effects of man-made structures, particularly in respect of longer term or wider field and regional effects. So just to show you how we've gathered this evidence, we've applied the protocols and so on from gathering environmental evidence and synthesizing environmental evidence. So we produced a systematic map of all the literature, published literature looking at the ecological environmental effects of man-made structures in the sea. We found about over 20,000 potential papers on that, and through processes we whittled those down to a little under 1,000. And that map, it's effectively a big spreadsheet. It's available, open access, online. It's already being used in our research, and it's already been used by other researchers elsewhere as a very quick and simple way of finding where are the appropriate papers to cover whatever it is you're interested in. And that is a major output from the DREAMS project. We have been through those papers. Here is the evidence that most of them are on fish and invertebrates. And here is just showing where the gaps are. So these red and orange colors are little or no information. We have a whole range of different potential things we might be interested in from a biodiversity perspective. We also looked at different man-made structure types. So there's oil and gas, there's also artificial reefs, offshore wind, shipwrecks, renewable energy devices, cables, pipelines and things, and so on. And you can see that most of this is red. We have very little published evidence of any of the effects of any of these things on any of the biodiversity. Most of it is very clustered around fish and invertebrates. And there are a few papers on birds. Well, there are several papers on birds and so on, plants on artificial reefs and so on. So there are big opportunities to expand our knowledge base. We then went through the papers using another structured process and extracted data that's relevant to the effects. We chose to look at fish and invertebrates because we had enough information to work with. And what we're trying to do here is to compare the effects of different types of structures with each other and also with different natural backgrounds. So here we're looking at differences in a range of outcomes, abundance, biomass, and diversity, compared to natural soft sea sediments or natural reefs, and looking at the differences based on data extracted from about nearly 400 papers here. And this work is in progress, but we can see that there are differences in the effects of offshore wind, and oil and gas tend to have not much effect, compared with perhaps shipwrecks and artificial reefs. And this work will be developing, and we will firm all that up as we move forward. The take-home message is that although man-made structures affect biodiversity ecosystems, they may do so differently, but there are some general patterns in there. And these kind of meta-analytical approaches are much more robust than just looking at an individual study. In effect, we're bringing together lots of different studies to see if they tell us the same story. So here's another set of statements. Are the effects of man-made structures on biodiversity and ecosystems a reason to retain them, or should we remove them? This is highly relevant because at the moment in the North Sea, the presumption is that everything needs to be removed at the end of its active life, regardless of what it's doing. Leaving it in place is considered dumping, and also using it as an artificial reef, if it's oil and gas infrastructure, is also considered to be dumping. So the scientist's job is to provide evidence and thoughts about alternatives, and that's what we're doing here. We would say that the communities on and around man-made structures may be considered either beneficial or detrimental to conservation or other policy objectives, depending on how those are framed and how they are implemented. In some parts of the world, for example, commercial and recreational fisheries are supported by man-made structures, whereas in others, they are excluded from man-made structures. So there are decisions to be made. Likewise, the role of man-made structures in providing islands of hard substrate and therefore increasing potential connectivity for larval stages may be considered beneficial or detrimental, as Joe eloquently described earlier this morning. Within the synthesis project, as I said, we sampled the brains of this group of scientists in all sorts of different ways. This is just one example of some of the outcomes. We asked them towards the end of the process, here are some strategic objectives from OSPAR. Do you think that if we do these different types of decommissioning, it'll move the system from where it is now towards or away from these various stated policy objectives? And we were able to quantify their input and process it and so on. So the colors here are green is strongly towards the stated objective, red is strongly away, and then yellow and orange are somewhere intermediate. The overall impression is that there are not that many very strong positive outcomes in here, and there seem to be rather a lot of reds and oranges, suggesting that all of these different decommissioning options may not necessarily achieve what it is that you're trying to achieve. The biodiversity ones are here, 5 and 6. 5 is protect and conserve biodiversity. And we can see that generally we thought that was positive, but the most positive one was just walk away and leave it in place, abandonment. Now that's rather politically difficult, but certainly the general positives there were is something of note, that some sort of leaving it in place or leaving part of it in place was considered to be a sensible option. And total removal was the least favored option, certainly for single structures. So that's quite interesting. And what about the scientific evidence base for decommissioning itself? How clear a view do we have of what the effect of removing a structure is? We can say that there have been very few studies that have considered decommissioning directly. The presumption or assumption is that removing the structures will reduce the potential for further contamination from the structures. It will also remove the biodiversity supported by the structures, but somehow it will allow the seabed to be in some way restored. But as Joe has already said this morning, the seabed as it is now is nothing like the way the seabed was 150 years ago. So what is it that we're restoring, or what is it that restoring actually means here? And the presumption for total removal ignores potential benefits of leaving man-made structures or parts of man-made structures in place. And it ignores the potential for legacy contaminants in the seabed around, or particularly oil and gas structures, to then become disturbed and resuspended by other activities, for example, by trawling. There is a strong preference amongst the scientists for regional strategies for decommissioning. Currently, individual structures are assessed for when they're being decommissioned, but actually it'd be better to have some sort of vision of what we want the North Sea, for example, to be like, and then to decide what to do with the structures collectively in some sort of strategic way. Just to clarify the evidence for that, we could only find 57 articles that looked at decommissioning directly. They looked at, most of them were about oil and gas infrastructure, particularly in the States, but there is some in the UK, and we hope that there will be more moving forward. When we asked the scientists, as one of the exercises we did, we gave them a perception study. They had provided us with about 400 different effects. We then grouped those into different types of effects, and we then asked them, the scientists, to say, given these effects, would you want to retain or remove structures from the environment? And we can see that very few of the effects were viewed by that group of scientists as being very strong reasons for leaving them in place. There were a few, particularly to do with fisheries. As I said earlier, in some parts of the world, there is very strong evidence that some commercial fisheries are supported by nursery habitat within the structures and so on. But there was a thought that generally the physical structure, connectivity and hydrodynamics were viewed as worth retaining, and generally none of the other main effects were thought to be reasons for leaving the structures in place. We also, just to address the point that was made by both Joe and Tom about moving forward, thinking about ecosystem services, natural capital, net benefit, and all these other things. We've been through part of the systematic map, adding information about ecosystem services. In effect, this is adding extra columns to the systematic map spreadsheets. Thinking about how different activities may enhance or reduce different ecosystem services. And here we're looking at the different strategies for decommissioning structures in the sea. So they're things like protect in place, or remove part and add protective structures and so on. Again, we have a scale where red is pretty bad, and we can see that it looks as though full removal, or things related to full removal, complete removal, are generally considered rather bad from an ecosystem services point of view, which is quite interesting. We also have the point that nothing suits everything. So we can have situations, this is biodiversity here. Biodiversity is considered the final service. And of the different decommissioning options, we have some that will substantially enhance that, which would be to remove part and add protective structures. Some will degrade it a lot, which is full removal. And then some of the other options are intermediate. So we have trade-offs, the idea that we do different things and different things happen. So in summary, while a considerable amount of research has been conducted and published, there are still very large gaps in our understanding about the interactions between man-made structures and biodiversity. Research may provide answers to policy relevant questions, but this is not always possible, and other methods of developing a robust evidence base may prove useful. Although man-made structures may affect components of biodiversity, these effects are generally fairly local, and wider scale effects, particularly of networks of structures, and I'm thinking of what we're doing in terms of offshore wind, for example, now, are poorly understood. And trade-offs are everywhere, and trade-offs are complicated. Thank you. I think that's what I want to say.
Thank you very much, Paul. As you know, I always find your work fascinating, and right at the pointy end, upward policy. So hopefully we can have some more discussion about that later. Before we get into the Q&A, we're very fortunate to have Victoria Metheringham from DEFRA here. Victoria sits in the evidence team in DEFRA, and she's going to give us just 5 minutes of some of the things that are, I guess, concerning the DEFRA scientists at the moment. Victoria, did you have a slide you were going to put up?
Yeah, I do.
You should just be able to share your screen.
Okay. Okay.
Perfect.
Can we see that?
Put it on full. Yeah, put it on full screen, and then if you can. There you go. Perfect.
Okay, great. Hi, everybody. Thanks for the introduction. So yes, I work in the Marine Biodiversity and Environment and Monitoring team in DEFRA. We provide support. We're a supporting function for multiple policy areas across marine and fisheries. I just wanted to note before I go on, when I'm sort of speaking on behalf of DEFRA in terms of the offshore region, we cover English waters, and for the rest of the UK countries cover their own areas. But first of all, thank you very much for such great engagement and discussion with INSITE. We've really appreciated the involvement so far. We're really excited to be involved and to hear about all of the work that's going on. The INSITE programme is of really great interest to us here in DEFRA across several policy areas and their supporting evidence teams. It's specifically useful for UK marine strategy in achieving good environmental status, marine spatial prioritisation, marine licensing, which I list off my list here, around assessments such as HRAs and SEAs. It will help with supporting and complement the work that we're already doing under the Marine Natural Capital programme. And at the top of the list of how INSITE is particularly useful to us right now is around marine net gain and OEAP, the Offshore Wind Enabling Action Programme. So this is just a slide of hot topics, and it is a recycled one that I've just quickly updated. I wanted to make it relevant for this biodiversity theme, so it's not an exhaustive list. We are doing a lot more work that's just on here. And also I wanted to crucially say this is not in order of importance. Everything's important. It's just a list, just wanted to jot down and give you some ideas of the key policy areas that we're working to at the moment that I thought were kind of relevant. So I'm just going to pull out a couple of those areas. The one at the top, I'm not going to go into detail on the British energy security strategy, but this has noticeably stepped up our ambition and the speed of our ambition in developing offshore wind, and alongside it, an offshore wind environmental improvement package. Basically, the plan is to accelerate deployment while enhancing and protecting the marine environment. We want both. You will have seen DEFRA's Secretary of State a couple of weeks ago made the announcement on the Environmental Improvement Plan, which also set out marine net gain. So this is a developing policy area that's working alongside our offshore wind policy and marine spatial prioritisation and UK marine strategy. I wanted to mention that because I think it's often a worry externally and internally that government can work in silos. And I wanted to make it clear that the marine net gain work is strongly integrated. So the main areas that we are looking at regarding the stepping up of offshore wind development, which I think are most relevant here. I know that a lot of the work in INSITE is offshore man-made structures, but obviously increasing the ambition of offshore wind, this is where we're particularly interested. So the areas we're really want to get stuck into the detail of and find some supporting evidence around are measures to compensate impacts at a strategic level. So if we understand measures to compensate impacts at strategic level, this will in turn assist us in understanding if there are any specific standards to apply that will help with consenting and assessments. We also need to deliver a strategic approach to environmental monitoring. We are working with the ALBs on strategic monitoring and best use of data. So there's a lot of work already underway that work like INSITE will really be able to help and support with. So how can INSITE help? So I've pulled out some key gaps which I felt were really relevant to the work that you're doing. And just listening to the presentations then, it's quite clear that you're already on on the path of answering some of the gaps that we have. So we're really interested in nature-focused design. So we're not just looking for accidental or incidental benefits for nature from a structure at sea. We want to see intentional design that will deliver environmental and biodiversity gains, which leads us on to the next question. Is this really a net gain? These are things that we want to know. We will need to see evidence that it is a gain and not just a replacement like for like. So we need to be able to see evidence of that. We want to know what are the circumstances that have made a difference, positive difference. We want to know what are the circumstances that have led to a positive difference for biodiversity, for environmental gains. Is it about the design? Is it about the materials, the location, the scale? And what was the difference? Was it significant? These are the type of things that we would like to know. And there's also some particular questions which we're really interested in around the food chain. A lot of this work could potentially help us with good reporting on good environmental status for the UK Marine Strategy as well. So what are the food chain impacts associated with any of this? Are there any measurable improvements here? And we'd also like to see clarification on any impacts of the food chain, of whether it's potentially just behavioural, or whether what does it mean? What will it indicate to any species that are impacted? We really want to see what the change is and how it was tested, and does it demonstrate a positive impact? So I think that's kind of it really. I'm going to wrap it up. DEFRA would really welcome supporting evidence to assist us in developing these policies so we can maximise the benefits for biodiversity and the environment, while hopefully not creating too much complexity for developers and delivering our energy targets. So not too much of an ask. But I think that's it in a nutshell, really.
No, thank you, Victoria. No small task in front of you then, I don't think. Great, thank you to all our speakers. We have a bit of time now for our Q&A and a panel debate. So hopefully we will be moving on to that now. Perfect. So you should be able to see all of our speakers on the screen in front of you, and we also have our illustration there, which is looking great, which we'll come back to at the end when we wrap up. But that's looking really great. So we've got several questions for everybody, I guess, and if those people, so yeah, Tom, yeah, we've got everyone on camera, which is great. So what I'm going to do is go through the questions. We've got them in order of ranking, but I'm going to divvy them out equally to you, I guess. And so Joe, I'm going to come to you first. We've got a question from Anna Trevera on what are your thoughts of the introduction of artificial hard substrate in protected sedimentary habitats such as Annex 1 subtidal sandbanks? And I know this is a incredibly hot topic in the offshore wind industry at the moment. I don't know whether you can give any reflections from some of your work on that.
Yeah, that's a very tricky question. But thanks for asking that. And I was actually in a workshop, I think, last year on exactly this topic. And gosh, I think we have to really look at why are we wanting to bring the hard substrate into that kind of habitat? I mean, this is such an open question. What are the particular, would there be an impact on the structure of the habitat, the physical, you know, and are the key species that would be impacted if you put a hard substrate in there? I mean, just try to bring it to life a bit, you know, sandbanks can often be important for things like sand eels, which are, you know, important then for higher up the trophic level. And if you fragment the habitat, you know, that that could cause a problem higher up in the food web. So it's just understanding the individual cases, I think, rather than trying to generalize there. Maybe in some areas, it's not a problem, but maybe in other specific areas, it is a problem for very specific species or impacts on the habitat. So I'm not sure if I'm really answering the question there, but those are some thoughts that come to mind, Anna.
Great. Thanks, Joe. Yeah, it's an incredibly complicated topic that is, I know, really testing offshore wind developers at the moment as they're looking at putting cable protection across places like the Dogger Bank. Great. I'm going to go to a specific question for everybody, and then there is a question from Claire that's a bit more of a general one. But Tom, I'm going to come to you next. There's a question from Kai Ferguson about what can industry do to ensure you get the standard and type of data from various environmental surveys conducted across the project timelines. And I know this is something that you and your team have been working quite closely on. I'd be interested to know your thoughts.
Yeah, well, thanks for that question, Kai. Yeah, we're developing a standard operating procedure for ROV pilots to optimize the data collection for 3D model generation and auto ID. I mean, in short, that ROV survey should be done in a sort of lawnmower pattern with as much crisscrossing as possible, so that the same part of the structure is imaged from multiple angles. Ideally, a stereo pair of cameras would be involved so that the model can be scaled much better. And with a stereo pair of cameras, and these are high definition cameras, with a stereo pair, the software will auto calibrate itself between the images produced by that stereo pair. But there's a few other technical details which I can share with you about how to optimize for the sort of biological purposes, as well as the more the engineering aspects.
Great, thanks, Tom. And yeah, I would say that if anyone wants any more technical detail about what Tom's talking about, then please do get in contact with him afterwards. So Paul, I've got a question for you next, from Christina. How would different decommissioning practices impact on EIA and siting of infrastructure? For example, would a leave in situ approach mean that presumption against development in benthic MPAs would need to be in place, as this would have permanent impacts rather than temporary or long-term impacts as they're currently assessed? Again, quite a complex question.
Too many words for me in a rather short period of time. I think the question is, how can we change things when they are the way they are? What we're talking about is maybe we need to be more imaginative. Maybe we need to change the way we view things. Maybe we do want to take a long-term perspective rather than just what we do with this structure now, and actually have a view of what we want the system to be like. Why do we want to restore the situation to a damaged situation to start with? So that there are very complex and complicated discussions and decisions that can be had, that may well go against the grain of where we are at the moment. We do things as they are at the moment, but how do we change that? And in part, that's what we're looking at in Dreams. It says, let's imagine a different world. At the moment, everything has to come out, but what if we could leave some of them, or even discuss leaving some of them in place? Would we get a different set of decisions? So that's where we're at. So at the moment, it was about EIAs and MPAs, and the presumption that if we allowed the structure to remain in an MPA, it would be there forever, and therefore we could never put it in place. You can have different decisions made in different places for different reasons, and sometimes it's less damaging to leave something alone rather than it is to take it out. I mean, one of the long discussions we had within the synthesis project was about what would happen if you took everything out and just trolled it immediately afterwards. And there was a lot of concern about long-term contaminants in the sediments and so on, and maybe that's not a good thing to do, to stir them all up and spread them all over the place. And maybe it'd be better just to just leave a bit there, just to discourage some alternative human activities, as we like to call trawling. And you know, so a long-winded answer to a very straightforward question. I think we should dare to consider alternative options, even if it's just at the consideration stage, to ask ourselves, is what we're doing now sensible? Because as some of you know, I have quite strong views about the fact that a lot of what we do now is not actually what we would do if we designed it all from scratch.
Yeah, thanks, Paul. I think it's really a point Christina makes about the unintended consequences of different actions that that are important, that you work all those through in terms of when you're looking at changes in decision making. Great, thank you. Yes, Paul.
Just to extend that slightly and to address some comments that Victoria was mentioning, sometimes we can't just provide evidence. There was a strong requirement for evidence, and we were just, you know, I'd just like to go back to the fact that with this considering different options thing is more an imaginative process often than a evidence-driven process. And one of the things we tried to do in the synthesis project was to operationalize that, so that we can have some statistically robust evidence that isn't necessarily gathered in the field from a research vessel.
Yeah. Yeah, and having been involved in the policy process for some of my career, I think it's, yes, you're absolutely right. The outcome that you're aiming for when you're looking at policy is a mixture of what the science is telling you and what you want to do. And those two things need to be as aligned as possible. But the science can support several different outcomes that you might want to go to. So it's important that we kind of think about that. So great, thank you, Paul. Victoria, I'm going to give you a question next, if that's okay. So there are two questions that are kind of the same, one from JF and one from Celestia, about your engaging both with OPRED and OSPAR on decommissioning approaches for oil and gas, and yes, how that is kind of operating.
Yeah, so definitely it's not myself. My colleague, head of UK Marine Strategy, is completely embedded in that work. So we are involved in the discussions. He is part of OPRED, and he's involved in the OSPAR discussions as well. It's Andrew Scarsbrook. Can't tell you our position. It's just at the moment, OSPAR says we need to decommission. That is the position at the moment. But we are involved in the discussions, and you know, I think that's pretty much all I can say on that, really. It's not my work area, but yes, DEFRA are involved.
Great, thank you, Victoria. I'm going to go back around the room again, I guess. Joe, I've got a question for you about your, I guess a technical question about your test sites. Are they all similar in terms of height in the water column? Are they all on rig legs, turbine bases, or some on mattresses close to the seafloor? And is that being considered in your analyses?
Yeah, thanks for that question. So just to clarify, we're not putting our collection panels directly on infrastructure. We've designed a standalone unit of deployment. So it's in the vicinity of infrastructure, but not directly attached to it. And what we've decided to do to standardize is to just have the panels suspended at a specific height below the water surface, so that we've got that comparison of what's happening at that level in the water column. And that's really the best we could do, because the sites are very different in depth, and also because the environment's quite tricky to work in, as we know. We've had to account in the design for the moorings to be flexible to withstand the conditions. So some of the moorings have got elasticated strops in them to withstand issues with waves and so forth. So the best way to standardize was to have the panel suspended at a similar position across all the different sites. I hope that's answering your question, Becky. Thank you.
Thanks, Jo. And Tom, I'm going to come to you next. There's a question from the European Marine Board representative online saying, would it be possible and useful to have cameras installed on offshore structures in addition to monitoring by divers and ROVs, so you can track biodiversity settlement as you get a given view of part of the structure would be representative of the whole of the structure. So I guess would cameras in situ, do you think that would give you, I guess, much more additional benefit than just taking snapshots over a period of time?
Yeah, I mean, I mean, it would give you the time element, wouldn't it, to enable you to assess change over time in more detail, and if that was of particular relevance to the requirements of the study, then obviously that would be useful. I mean, the biofouling community tends to reach a sort of climax after relatively short time. So if you are looking at in a sense what is the biodiversity associated with structures in the longer term, that should be relatively constant. It would be possible to train a machine to look at elements of that biodiversity arrival, and that could be telemetered back in real time, conceivably. That's technically possible. Again, it would really depend on what the objectives of the survey were as to whether that would be sufficiently useful.
Great, thanks, Tom. Victoria, well, actually, I'll come. I think we've got one for. I tell you what, I'm going to ask this question at the top from Claire to you, Paul, and then see if anyone else has got anything they want to add into it. So, talking about evidence for possible contaminant leaching from offshore structures that could impact on efforts to improve biodiversity, particularly if things are left in situ. And I know you discussed this quite a lot in your synthesis project workshops, didn't you?
Yeah. Yes, I did. Sorry, I think my mic might have got knocked earlier on, so I apologise if I've been just mouthing at everybody. Yeah,
no.
Legacy effects of contaminants was something that really concerns the scientific community. And we're getting better at looking at, for example, microbial communities in the sediments around structures, which are not things that we've traditionally looked at, but Natalie Hicks from the University of Essex and others have been looking at those. And there is one of the reasons why you might want to retain at least part of a structure in place is to prevent the sediment from being ploughed up and turned over when we know that particularly around a lot of these older structures, there was considerable contamination. Much of what OSPAR has achieved over the years is to reduce and clean up many of the effluents and outputs from operational structures, and that's been really good work. So a structure going in now would have all sorts of restrictions placed on what is done and how it's done, compared with one that was put in place in the 70s, where it was effectively just towed out and stuck in and started drilling, and that was it. It was like the Wild West in some ways. So legacy contamination is one of the reasons why scientists think leaving some of these structures in place might be a better idea than trying to pull out every last bit.
Great,
and I was just reading
Paul.
a paper the other day about a shipwreck from, I think, the First or Second World War off the coast of Belgium. Always bear in mind that it's not just oil and gas, it's not just artificial reefs, there's all sorts of things out there, especially shipwrecks. Joe can probably tell you, I think it's like 60,000 or 600,000 shipwrecks lying around on the seabed. And we don't go out and decommission all of those for some reason. But the legacy contaminations from that are still ongoing. So
Great, thank you, Paul. Yes, lots to think about there. Victoria, I'm going to come to you next. Again, it's a question that's probably not your complete area, from Jerome, talking about net gain. and developers being required to consider impact and net gain. So they consider impact through EIA and net gain through, I guess, the Environment Act and then whatever else is going to be coming forward. There's a question here about, will the fishing industry have similar requirements to consider impact and net gain? And I know they already do under the habitats regulations. I don't know if you can give us an update on net gain.
Yeah, I can't in relation to the fisheries, I'm afraid. Because I just literally don't know the answer. So I don't know the answer, but I can try and find out for you and get back to you. But I know that the Marine Net Gain team, they're currently working very hard on providing a response to the consultation. So the consultation that happened last year, and they've been going through that, and they are going to be responding to that quite soon, I believe. So there will be information in there, but yeah, I can't answer that specific question, unfortunately.
Yeah, I have no doubt it's a question that they are considering quite hard at the moment. And I know certainly, Jerome, for the habitats regulations, fisheries wasn't considered, but has been for like the last 5 or 6 years, and we're starting to see the first bylaws coming through offshore in relation to that. And yeah, so it will no doubt be considered as well. And Victoria, just before we move on, there's a question that, well, I guess a comment from Jim asking if you can connect with him about some of the work that Natural England are doing on GES.
Yes,
which I presume is a yes.
Yeah, definitely,
Okay.
Jim. Yeah, it'd be really good. It would be really of interest to Marine Natural Capital team and obviously the UKMS team as well. And I think there was another question about whether we saw offshore wind as an opportunity to learn more about food chains. And yes, we do. Obviously, you know, when I've said that wish list of all of the things that we want, it is a wish list of like all of the things that we would like in DEFRA, but we do understand it is a balance. We can't get everything that we're asking for, but we're just putting out there where it is that our current sticking points are and the things that we would really like to have more information on.
Yeah, okay, great, thanks, Victoria. So we've got one more specific question that's directed at you, Paul, and then the rest are kind of to everybody. So I'm going to pick a few in the time that we have left. There's one from Becky Hitchin asking, from a policy perspective, the work that you're doing in Dreams and the Synthesis Project, Paul, if you can isolate information from MPAs and non-MPAs to see whether there are any differences in there, particularly in informing the ongoing development of MPA conservation measures. And I don't know whether that's something you're able to do or not. I guess it's a spatial delineation of your data in some way.
It's not really, yeah, it's not really spatial data. It's just it's you know, pointing you towards large numbers of published studies on different things, from which you can then extract real data if you want, and that's what we're doing in the meta-analyses. So potentially, yes, we would have a column in the, and I'm fishing here because I can't remember. Within the systematic map spreadsheet, there are a whole range of factors that you can use to select groups of papers, filters, if you like. And I can't remember if MPA, not MPA, is one of them. It certainly could be one of them. So have a look, it's online, it's open access. If it doesn't do what you want it to do, get back to us and we can maybe modify it moving forward. What we have looked at is, it was quite interesting actually. We in the meta-analyses, we had shipwrecks as a category. So we were comparing shipwrecks with artificial reefs, with oil and gas infrastructure, with offshore wind infrastructure and so on. And it did make it quite a considerable difference when we decided that actually shipwrecks that have been deliberately put there are really artificial reefs rather than shipwrecks. And so when we did that, it changed quite a lot of the outcomes. So a shipwreck that has been wrecked, as opposed to a shipwreck that has been effectively dumped, to use the oil and gas terminology, are not necessarily quite the same things. So the answer is maybe, and get in touch with us and we can talk about it.
Brilliant, thank you, Paul. So I now have a question from Martin Lilly from DEFRA. That's really interesting. I know that in the Insight programme, we've been going for 10 years, so we're focusing mainly on oil and gas infrastructure, and looking forward, we're starting to focus on fixed offshore wind, and I know that some of the sort of transition conversations going on between INSITE and the Offshore Wind Evidence and Change Programme and the Eco Wind Programme and all the kind of other offshore wind work. Martin's got a question that's, I guess, with a further time horizon. Do the speakers think that floating offshore structures will have the same ecosystem service impacts as fixed structures? There's an interesting question, I think, from all of your perspectives around the things that grow on them, how that affects connectivity, what we should do in a decommissioning phase. I'd be interested to know your thoughts on that. Who would like to go first? Paul, thanks for jumping in. And then Tom. Yeah.
One of the things that I said about the insight synthesis approach was that it allowed you to address questions that can't be addressed using direct research. For example, we don't know anything about the ecosystem effects of large networks of floating offshore wind because there isn't any. So we have to make it up or model it in some way, or ask scientists what they think in a structured way. And that was quite interesting. So we do think that floating offshore wind will have in some ways fairly similar effects to fixed, but obviously they'll be in deeper water. There'll be we're building models to be able to look at the effects of floating offshore wind. And the question was in terms of ecosystem services, right? So
Yeah.
so that will depend on which parts of, I mean, the structures have to be moored, so they will affect the seabed. The structures will have that surface bit that does a lot of the ecosystem service provision, fixing carbon and filter feeders eating phytoplankton and converting it into detritus that sinks to the seabed. You'd imagine all that will still happen. It might be a bit more diffuse at the seabed, but it depends on what the densities of these things are. You'll still have the rotors going round and doing what they do and so on and so forth. What's missing is the bit in the middle. You're replacing a large pylon generally, or a monopile, with a set of cables. And it'll be interesting, but I would imagine, and the results from the insight synthesis back this up, because we did ask them about floating offshore wind, knowing that nobody really knew what the answers were. So we thought that would be an interesting thing to do. And generally, they thought it would be fairly similar to fixed offshore wind, if that's an answer.
Yeah. Thanks, Paul. Tom.
Yeah, I would just sort of concur with that, really. I think the zonation will be the same. So the zonation between, if you're in deep water, between corals at the bottom, if you're in the North Sea and you're less than 60 or 70 meters up through a sort of Metridium communities, and then with Mytilus at the top or macroalgae at the very top. I think that's likely to be very similar to existing structures. I think that a major aspect of the change associated with these developments is around access change, and there will be a degree of access change as a consequence of floating offshore. Whether that's as permanent as it would be with a fixed offshore structure, I mean, I don't know, but there will be exclusion presumably of bottom seabed fisheries. And as Paul said, I mean, it's still attached to the seabed, albeit via a riser, which a mooring system which is more flexible. There may be different access by support vessels as well, which may affect the consequences of this type of offshore wind development.
Great, thanks, Tom. And Joe, you've got your hand up.
Thanks. Yeah, just to add just a tiny bit on to what the others have been saying, just thinking about the anchoring of the floating offshore wind, probably be a little bit different to what we've seen with the other technologies. So there's probably some opportunities there for ecosystem service enhancement, thinking about the design of the anchoring systems. So just wanted to add that to the mix. Thank you.
Thanks, Joe. We've got probably another 5 minutes, so I'm going to consider another couple of questions, both which are general ones. Tom, there is a specific question for you from Tim that I guess if you could answer very quickly, where he's asked about, for auto ID of 2D images, patterns of pixel values are learned, what 3D properties are learned for the auto ID of your models. I don't know if you can answer that sort of quickly and succinctly, and we'll get on to the last two.
So briefly, at the moment, we're not extracting 3D. At the moment, we're not extracting 3D information to inform the auto ID. It's effectively, the auto ID is based on a standard image, and then it's stitched together as part of the mosaicing process. That means that, and you will have seen this possibly, that the same object can be identified as different taxa, which of course is not correct, and as part of the technical challenge is to identify where a taxa is and what gets the largest number of votes from the machine to optimize that process. We are looking at ways of including 3D information into the training process, though, through a part of INSITE, but that's very much ongoing work.
Great, thanks, Tom. So I'm going to go with a couple of questions now. There's one from Mike Elliott, and then there's some two broader questions I'm going to pull together about restoration, which bring us neatly onto our next webinar, I think. The first one's from Mike Elliott, who is, of course, part of our INSITE community, asking about the context scale of the problem. The Southern North Sea had 25,000 kilometres squared of reefs and outcrops, and the hard area of man-made structures, installations, maybe around 8,000 square meters. Do we give a misleading impression when we map the structure? So this is a scale thing, I think, about both of what we've got in at the moment, but also what we could have in the future, particularly if we're looking at our ambitions for fixed offshore wind in the North Sea. I guess that scale question, it'd be interesting to know how you're all looking at that. Would anyone like to comment first on Paul?
Thanks, Mike, for the question. I know you're interested in ecological footprints and all the rest of it, and but I think it's a very useful thing to bear in mind, the actual scale of the problem. In our DREAMS project, we've been modelling the North Sea at the North Sea scale and putting structures into it and out of it, and they have very little effect, as you might expect, at that scale. So whereas locally they can have very big effects. So the question at what is it that you want to achieve should be what predicates what matters and what doesn't. We should be able to ignore things where we have the evidence that they can be ignored, if that's the way of putting it. So in the Southern North Sea, there are lots of structures. From a connectivity basis, they might be really important. It's not always just about the area of the structure or the amount of habitat. It could just be crucially where it is and when it's there that matters as much. So we're just trying to get a better understanding of the whole thing, really.
Great, thank you, Paul. Tom, Joe, do you have anything you might want to add on that question of scale?
Yeah, I can comment just very briefly, if that's all right.
Yeah.
I would say that natural reefs, certainly in the North Sea, to my knowledge anyway, would be relatively low relief and quite different from artificial structures, at least of the type of oil and gas or surface penetrating renewable structures, and so that they are quite different structures. So that they're not natural reefs, these artificial reefs of that type. And they exist in different parts of the water column, and then they communicate with each other in different ways because, for example, of the stratification of the water column. I think these are all issues which separate natural reefs from us, at least some artificial reefs.
Great, thanks, Tom. Joe, did you have anything you wanted to add to that? It doesn't matter if not, because we've got just a couple of minutes for the next question, but if you do, then that would be great.
Yeah, I'll just come in briefly, Dickon. So I just building on from what Tom said there, yeah, I think just understanding a bit more about how connected the artificial versus the natural reefs are, understanding that better might be able then to answer the question that Mike's asking, but I think at the moment that information isn't there. Thanks.
Thanks, Joe. And Before I wrap up, we've got 5 minutes left, so literally just a couple of minutes to this. We've got a question both from David Santillo and from Kai Ferguson, basically looking at net gain and environmental restoration, which, as a plug, is going to be our next webinar. So do come along if you want to have more detailed chat about that. David's making a point about that we have clear but separate guidelines to enable the construction of artificial reefs, separate to the decommissioning of man-made structures. So should there not be more focus on implementing those artificial reef guidelines and less on changing the rules for decommissioning? Kai Ferguson's talking about, does DEFRA consider upcoming offshore developments as an opportunity to further our understanding of positive impact on the food chain? I don't know, Victoria, I know you don't sit in the OSPAR facing team in DEFRA, so I don't know whether you probably can't comment on those in detail, but I don't know whether you can give any comment on sort of around environmental restoration or net gain type areas.
Well, I can on so around the UK marine strategy, the food chain and biodiversity descriptors are the ones that we're really keen to look at new information coming in and considering different ways of how we assess against those descriptors. And absolutely, we're very interested in the developments offshore and how this can potentially supplement how we report against those descriptors for UKMS. So that there is we do see this as an opportunity to help us, and the food chain descriptor is one that we're looking at. So I would say that's a big yes. Around I can't really answer anything on net gain, I'm afraid, because it really isn't my area. I'm getting the odd message from the DEFRA person in the group on me chat, but I haven't got one at the moment to help me on marine net gain. But marine net gain colleagues will be here for the next one, I'm sure.
Great, thanks, Victoria. And David, just on the bit about decommissioning or artificial reef guidelines, I believe that if you have a oil and gas structure, you have a requirement to abide by the decommissioning guidelines alongside the artificial reef guidelines. So it's not a question of one or the other, it's probably both of them at the same time. Very quickly, Paul, because we're going to have to close in a moment.
People are talking about decommissioning as if it's complete removal, and actually what part of the point is decommissioning can involve other things like creating artificial reefs, which is what they do in Gulf of Mexico, it's what they do in California, it's what they're thinking of doing in Australia, it's what we're not allowed to do in the North Sea, and that was part of the motivation for an awful lot of this work. Can we at least just consider different decommissioning options? And that's what we've been doing.
Great, thanks, Paul. Victoria?
Yeah, just completely forgot to mention this. We are considering artificial reefs, and it's something that we're looking at internally on how they potentially play a role. But I mean, that's pretty much all I can say really at the moment on that.
Okay, great. Thank you, Victoria. So we have 2 minutes left. So I'm going to wrap up and just say thank you very much to all of our panelists and all of you for attending. This is a first of the Insight webinars, and I should also really like to thank Bea for the amazing illustration which you can see on your screen there, which has pulled out some of the key messages for today across the exciting projects that we're doing in Insight, and we will be making this available to people as well, just as a reminder of the key messages from the webinar today. So thank you very much, it's totally amazing. I'm in complete awe of people that can do stuff like this. So yes, thank you very much, Bea, for your contribution today. So it then just, I guess it's up to me to say thank you very much to everybody for attending. Our next webinar is going to be on Tuesday, the 18th of April, and will be on environmental restoration. So yes, hopefully we'll have lots more talk about net gain. And I'm sure it will be equally interesting. Thank you all very much for attending today, and we look forward to seeing you in the future. And again, thanks to all our panelists for excellent presentations and discussion at the end there. Great. Well, I hope you have a great rest of the day, and we will hopefully see you in April. Take care. Bye.